You're standing next to a huge floor-to-ceiling window of the spaceship/wandering city you've been calling your home for a dozen years, along with a few hundred other people. You're watching a fascinating object nearing your spaceship, wondering if it'll bring an end to this journey and your life. It looks like an asteroid, but acts like a comet, moving as if something is pushing it. Can it be the engine created by another space civilization? Are you doomed, or are you about to have contact with a different kind of intelligence? Now, let's leave this post-apocalyptic fantasy and take a closer look at these space invaders called dark comets. The most intriguing question is obviously, what makes them move? Most likely it's some gas or material escaping from the surface of these space objects. Interestingly, until recently, no one has even been sure they existed. The first dark comet was discovered just a few years ago, and since then, researchers have identified 14 of them, including 7 new ones found just recently. The story of dark comets began in 2016, when scientists noticed something strange about an asteroid called 2003 RM. Its orbit wasn't quite what they expected. It had shifted slightly, and no one could explain that shift by typical asteroid behavior, when they received tiny pushes caused by sunlight heating an asteroid unevenly. Instead, the movement suggested that 2003 RM might have been releasing material, something comets often do. But there was a catch. The thing didn't look like a comet. There was no tail, no visible gas cloud. It was just a tiny dot of light, like a regular asteroid. At first, scientists thought 2003 RM was just a one-off mystery. But in 2017, a telescope spotted another strange object, this one from outside our solar system. It was Oumuamua. It too looked like an asteroid, but had a path that changed as if gas were escaping from it. The similarities between Oumuamua and 2003 RM made researchers think there might be more of such odd objects out there. By 2023, 7 more had been discovered in our solar system. These discoveries were enough to give this new type of object the name of dark comets. Now, scientists have enough data to start noticing patterns and learning more about their characteristics. And so, they have identified 2 main groups of dark comets. The first group, called outer dark comets, is larger, with sizes ranging from hundreds of feet to even more. They follow long elliptical orbits, similar to traditional comets that come from regions near Jupiter. The second group, inner dark comets, is smaller, usually tens of feet across. These comets move in almost circular orbits and stay closer to the Sun, near planets like Earth, Venus, and Mars. The main question these days is, where do dark comets come from? Can they be the remnants of larger bodies that broke apart? These space bodies could help us understand the history of the solar system. What if they had delivered the ingredients for life to early Earth? Once we study dark comets better, we might figure out if they contain materials like ice or organic compounds. And indeed, some researchers are sure that dark comets may contain or once have contained ice and played a big role in bringing water to Earth. According to a couple of studies, some asteroids in the asteroid belt, a region between Mars and Jupiter filled with rocky debris, might have ice beneath their surfaces, and this ice from the asteroid belt could have traveled into near-Earth space. In other words, it could be a pathway for water to reach our planet. So far, no one is saying that dark comets definitely brought water to Earth, but they might be another mechanism for moving ice from one part of the solar system to another. The study also hints at a connection between dark comets and a group known as Jupiter family comets. These are comets whose orbits are strongly influenced by the gravity of Jupiter, often pulling them inward toward the Sun. This connection makes it even more difficult to understand where dark comets come from and how they behave. Now, let's take a closer look at the differences between asteroids and comets. Traditional asteroids are rocky bodies that orbit relatively close to the Sun, typically within the ice line. This region is so close to the Sun that any ice on an asteroid surface would turn directly from a solid into a gas, leaving behind only rock. Comets, in turn, are icy bodies that form farther from the Sun. When they approach the inner solar system, their ice starts turning from a solid to a gas too, creating a visible cloud called a coma or a tail while releasing dust and gas. Dark comets blur these definitions. They appear as rocky asteroid objects without a coma or tail, but they have behavior typical of comets, and that's small non-gravitational accelerations. These accelerations occur when ice turns into gas, giving the object a slight push. After analyzing 7 known dark comets, astronomers estimated that between 0.5% and 60% of all near-Earth objects might belong to this mysterious category. And since dark comets likely come from the asteroid belt, ice is likely to exist even in the regions of the belt previously thought to be too warm. Now, near-Earth objects like dark comets don't stay in the same orbit forever. The near-Earth environment is unstable, and objects typically remain there for about 10 million years. Since the solar system is over 4.5 billion years old, this means that new near-Earth objects must constantly replace those that are lost. Now, astronomers have used computer models to simulate the movement of objects under the influence of non-gravitational accelerations. They've traced the paths of these objects over a span of 100,000 years and discovered that many ended up in the same regions where we find dark comets today. Now, do you remember that space rock 2003 RM, which was the first to be called a dark comet? Well, it provided a particularly interesting clue. Its elliptical orbit brings it close to Earth, then out near Jupiter, before returning to Earth again. This trajectory matches what scientists would expect from a Jupiter family comet, an object that was likely knocked inward from its original orbit. Most of the other dark comets studied, however, seem to have come from the inner regions of the asteroid belt, closer to Mars. Dark comets are often small and spin rapidly. Astronomers often describe them as dirty ice cubes, all because these objects are a mix of rock and ice, and when they cross the ice line, their ice begins to turn into gas. This process not only causes those small non-gravitational accelerations, but also increases their spin rate. And the faster these objects spin, the easier they can break apart into smaller fragments. The pieces that break off also have ice, and as they spin faster and faster, they break into even smaller pieces. This process continues until you're left with very small, fast-spinning objects. This cycle of fragmentation helps explain why dark comets are often so tiny. But it could also mean there are more of them than we currently know about. The dark comet research provides new insights into the distribution of ice in the solar system and its potential pathways into the near-Earth environment. It also raises intriguing questions. For example, how much ice remains hidden in the asteroid belt? Or could dark comets have played a role in delivering water or organic materials to Earth? One of the most important points is that dark comets may represent a significant part of near-Earth objects. If it turns out to be true, it could mean that our understanding of the population of near-Earth objects and their potential risks for our planet is far from complete. The processes shaping dark comets, from sublimation to fragmentation, could be a major factor in the evolution of icy bodies throughout the solar system. Luckily, these days, scientists have an opportunity to combine advanced modeling with observations, which can eventually shed light on that very elusive class of objects that could have clues to the history of water and life on Earth.
Comet 3I Atlas crashes into Earth, and a wave of widespread destruction starts shaking our planet. Ginormous tsunamis are swallowing coastlines, devastating earthquakes are cracking the ground. Hot debris is igniting massive firestorms. Thick clouds of dust are blocking the sun. Now, that's what could happen if 3I Atlas, a massive comet traveling through the solar system, collided with our planet. But can this disaster actually occur? When will 3I Atlas be the closest to Earth? Let's figure this out. First of all, this comet turned out to be way larger than we previously thought. Its weight is likely a whopping 33 billion tons. Let's throw in a few comparisons to put it into perspective. The Eiffel Tower weighs about 10,000 tons. So, 33 billion tons is roughly the weight of 3.3 million Eiffel Towers. Impressive! Next, all the cars on Earth, and we're talking about 1.5 billion vehicles, each weighing about 1.5 tons, weigh approximately 2.25 billion tons. This means that the comet's mass is 15 times greater than the combined weight of literally all the cars on the planet. And finally, compared to buildings on Earth, 33 billion tons is equal to several large metropolitan areas made entirely of steel and concrete. But the whole idea of how big this comet is fades in comparison with an even crazier fact about it. It could be unknown technology from a different galaxy, and some experts are somewhat sure about that. But why? 3I Atlas was first spotted in July by NASA's Asteroid Terrestrial Impact Last Alert System. A bit later, the US Space Agency confirmed that the object was an interstellar object, only the third we have found so far. Before, it was comet 2I Borisov that passed through in 2019, and Oumuamua, a weird elongated object that appeared in 2017. But the newest comet, with its up to 3.5-mile nucleus, dwarfs Oumuamua, which is just a quarter-mile long, and Borisov, which is about 0.6 miles across. By the way, some believe that the comet could be even bigger, up to almost 7 miles, but scientists haven't found any proof of that yet. Besides its size, 3I Atlas is different in other ways too, which makes some scientists question its origins. The object is shedding huge amounts of carbon dioxide and dust while zooming towards the Sun. It's most likely the proof that 3I Atlas is more massive than the other two interstellar objects by 3 to 5 orders of magnitude, which is basically a serious anomaly. The comet is also traveling toward the Sun incredibly fast. We're talking about around 130,000 miles per hour, which is almost 170 times the speed of sound. Another weird thing is that this interstellar object is following a straight trajectory, unlike anything else in the solar system. Most space bodies move along curved orbits due to the force of gravity. That made some researchers believe that 3I Atlas might be a probe sent by another civilization to explore Earth, possibly with not-so-friendly intentions. Their theory is that the object could be a technological artifact, a sign of cosmic intelligence. You see, the comet moves in a pretty weird way that doesn't totally line up with just gravity. Its trajectory also takes it close to Venus, Mars, and Jupiter. And researchers think that these planets might be especially interesting for another civilization to pass by. Another bizarre fact, the space traveler also spins backward compared to most stuff in our solar system. This might be necessary to make it easier for 3I Atlas to get near Earth without much resistance. Some scientists think the comet's odd spin and flight path could help whoever or whatever made it take super precise measurements of the planets, things like their orbits and sizes, to plan a perfect route through the solar system. If 3I Atlas suddenly changes direction in a big way, that might mean it's using some kind of built-in engine instead of just drifting through space. There's also another theory that suggests it could be a piece of unknown tech that's still active. There's no need to worry though, at least at the moment. The comet isn't coming anywhere near us. NASA says it'll stay around 150 million miles from Earth when heading toward the Sun. So the question is, where do such space visitors come from? Astronomers have found that the 3 interstellar objects we discovered came from totally different parts of the galaxy. And each of them has its own age and background. 3I Atlas turned out to be the oldest, about 4.6 billion years old, and it came from the Milky Way's thick disk. That's a region filled with older stars that have fewer heavy elements. 1I Oumuamua is much younger, around 1 billion years old. It came from the galaxy's thin disk, where new stars are still being born. Oumuamua, Hawaiian for a messenger from afar arriving first, was the first known object from another star system to pass through our solar system. Basically, the first interstellar guest. It was super stretched out, about 10 times longer than it was wide, unlike anything else we've spotted in space. It also sped up in a way that couldn't be explained by gravity alone. Changes in brightness showed it was tumbling end over end instead of spinning smoothly. At first, scientists were confused because the space body didn't have a tail or cloud of gas like a normal comet, even though it was accelerating. That led to a lot of debate about what it was made of and where it came from. Just like with 3I Atlas, some people wondered if it could be technology created by a space civilization. But most scientists now think Oumuamua was a totally natural object, just a really weird one. The best guess is that it was a comet releasing invisible hydrogen gas, which caused it to speed up slightly. Sadly, by the time astronomers found it, it was already heading out of the solar system, so there wasn't much time to study it. As for 2I Borisov, it sits in between at roughly 1.7 billion years old. It also came from the thin disk. It was the first confirmed comet to come from another star system, and it gave scientists a super rare peek at what materials beyond our solar system were made of. The comet was discovered in 2019 by Gennady Borisov, an amateur astronomer who actually built his own telescope to search for faint space objects. Unlike the first interstellar visitor, Oumuamua, which looked more like an asteroid, Borisov behaved like a classic comet. It had a bright coma. That's a temporary fuzzy atmosphere of gas and dust forming around the comet's nucleus as it approaches the sun. Plus, it boasted a long tail of dust and gas. Studying 2I Borisov helped researchers learn more about how other planetary systems form. Observations showed that its dust grains were compact and that the amount of gases like carbon dioxide changed a lot as it approached the sun. It could mean that the comet formed under very different conditions than anything else in our solar system. Now, 2I Borisov is speeding away from the sun and will never return. But it allowed scientists to take a unique glimpse into the chemistry and history of distant worlds. Interestingly, the differences between these three space objects suggest that interstellar visitors have been getting kicked out of planetary systems all across the galaxy for billions of years, so it's not something new. To figure out if 3I Atlas might be some kind of probe from another planet, scientists are checking for any signs of technology, like strange radio signals, electric activity, and weird movement patterns. If the comet suddenly changes course or drops smaller objects nearby, it might be our cue. But even though 3I Atlas is moving in a pretty wild and energetic way, it's most likely just a natural interstellar object passing through. Researchers say they'll need a lot more proof before anyone can seriously say the space wanderer was sent by someone from another planet. What do you think about this newly discovered space traveler? Share your opinion in the comments.
One of the biggest questions that has been torturing the minds of astronomers and common folks is, why haven't we found aliens yet? You'd think with a universe so big and filled with tons of stars and planets, we'd have already bumped into some extraterrestrial neighbors by now. This question was first asked by famous physicist Enrico Fermi during a lunch with his fellow scientists. They were chatting about UFO sightings and aliens, and suddenly Fermi asked, "Where is everyone?" It seemed like a casual comment, but it sparked a huge debate. If the universe is packed with stars, planets, and the possibility of alien life, how come we haven't seen any yet? This discussion gave birth to something we now call the Fermi paradox. It goes like this. Based on what we know, there should be advanced alien civilizations out there, perhaps even many of them. They'd likely have technology that could allow them to travel across space or at least send us signals to let us know they're there. But here's the kicker. Despite all of our technology and all the searching we've done, we haven't found a single shred of solid proof that these advanced civilizations do exist. So where are they? Over the years, a lot of theories trying to explain this paradox have seen the light of day. Let's talk about some of the most interesting ones. The rare Earth hypothesis claims that Earth might just be super rare, and planets like ours, with life, are incredibly uncommon. In this case, we could be the only planet in the Milky Way harboring life, or at least intelligent life. We might also be the first intelligent civilization in our galaxy to reach this level of development. In other words, we could be pioneers, however unbelievable it may sound. At the same time, it's not very scientific to rely on a rare chance. Some people think that maybe advanced civilizations were once here, but left the Milky Way. Perhaps they developed the technology of interstellar travel, enabling them to fly between galaxies. Or they could use other exotic ways, like wormholes, hypothetical structures connecting disparate points in space-time. Maybe they found more interesting and pleasant places to live far away from us. One sad possibility is that when a civilization becomes too advanced, it ends up destroying itself. Whether through war, environmental destruction, or something else, it could be that most civilizations don't last long enough to reach out to others. Now, imagine an advanced civilization being wiped out by a disease before they could even start exploring stars. In other words, it's possible that civilizations just don't survive long enough to meet others. Another hypothesis, not very flattering to us. What if these aliens are using technology that we just don't understand? Maybe they're communicating in ways we can't detect, like using signals beyond our current understanding of physics. Scientists are discussing such possibilities, but haven't found any yet. Aliens might also be intentionally avoiding us. They could be out there but staying silent, not so eager to reveal themselves until we're ready. Speaking of being ready, some people think that aliens could be waiting for us to reach a certain level of development before they make contact. Maybe they don't want to interfere with our growth until we're more advanced. Advanced civilizations could also go into virtual realities. And if they can live in digital worlds, they might stop caring about exploring the physical universe. Why bother? Another wild idea is that some civilizations might go into a type of hibernation, waiting for the universe to cool down, because it might be more energy efficient to do so. And last but not least, there's this creepy possibility that our entire universe is a computer simulation, and aliens are hidden from us on purpose. It's something like a video game that doesn't reveal all its secrets at once until you get to the next level. Now let's talk about the odds of life out there. We know that in just our galaxy, the Milky Way, there are probably around 20 billion planets that are roughly Earth-sized and located in the habitable zone, which means they're just the right distance from their stars to have liquid water. But how many of these planets actually have life? Could it be most of them, just a few, or almost none? And out of the planets that do have life, how many host intelligent beings with technology? In the 1960s, a scientist named Dr. Frank Drake tried to estimate the number of civilizations in our galaxy that could contact us. He came up with a famous equation, later called the Drake equation. It looks complicated, but the idea is pretty simple. It helps us calculate the number of intelligent civilizations based on things like how many stars are born each year, how many have planets, how many planets could support life, and how long a civilization might last. Here's what it looks like. Let's look into this equation in more detail. N is the number of intelligent civilizations that could contact us. R is the rate of star formation in our galaxy. FP is the fraction of stars with planets. NE is the average number of planets per star that could support life. FL is the fraction of those planets where life actually develops. Fi is the fraction where intelligent life arises. FC is the fraction of civilizations that can and want to communicate. L is how long these civilizations last before they disappear. The problem is, we don't know the exact values for most of these factors. So when we plug in numbers, which we know with large errors, we get answers with very large errors too. Depending on the values, the number of civilizations in our galaxy could be anywhere from almost 0 to tens of thousands. Right now, the best estimate we can come up with gives us a very small number, close to 0. In other words, even though our galaxy is huge, it's possible we're all alone here. Or nearly alone. One big reason we haven't met any aliens yet is that even if they do exist, we might not be able to visit them, at least not with our current technology. The speed of light is a hard limit in physics, meaning nothing can travel faster than it. This makes interstellar travel super slow. The situation could be better if there were exotic ways of travel, such as wormholes and warp drives. One day, they may turn out to be real, but so far, there is little hope for that. Even if we can't meet aliens face to face, there are still ways we might discover them. One of the biggest projects is called SETI, Search for Extraterrestrial Intelligence. SETI scientists use huge telescopes to listen for radio signals from distant planets. If an alien civilization is sending out signals, we might be able to pick them up. And if we have a very powerful telescope, we might use it to take super detailed pictures of distant planets, maybe even Earth-like ones, hundreds of light years away. This could give us a whole new way to search for signs of alien life. In any case, even though we haven't found aliens yet, the search is far from over. Whether it's through new technology, better understanding of physics, or just listening to the stars, we might one day find that we're not alone in the universe. Until then, the question, where is everyone, keeps sparking curiosity. A shocking theory claims that mysterious comet Oumuamua might be a von Neumann probe, an alien spacecraft with broken engines tumbling through our solar system. It sounds extremely unsettling, but first things first, what is a von Neumann probe? Mathematician John von Neumann suggested the concept of self-replicating spacecraft that could in some ways mimic the features of living organisms or viruses. People started to refer to such hypothetical spacecraft as von Neumann probes. Von Neumann was sure that using self-replicating spacecraft would be the most effective way to perform large-scale mining operations, like mining asteroid belts or moons. The creators of such probes could take advantage of their exponential growth. Hypothetically, a self-replicating spaceship could be sent to a neighboring planetary system and look for raw materials there. Such materials could be extracted from moons, gas giant planets, asteroids, and the likes. Using these materials, the probe could make replicas of itself. The replicas could then be sent to other planetary systems, and the original probe could pursue its main purpose within its parent star system. This pattern sure does repeat the reproduction patterns of bacteria. That's why some experts think that von Neumann machines could be considered a form of life. There's also a theory that a self-replicating spacecraft could spread throughout a galaxy the size of the Milky Way in just 500,000 years, even if it used conventional theoretical methods of interstellar travel. In other words, it wouldn't even need to employ exotic faster-than-light propulsion. In 1981, mathematical physicist and cosmologist Frank Tipler argued that extraterrestrial intelligence couldn't exist because people had never observed von Neumann probes. Even if we take a moderate rate of replication, such probes should already be common throughout space. So, it's really weird that we haven't come across any of those yet. It might only mean that extraterrestrial intelligence doesn't exist. A response to Tipler's arguments came from astronomers Carl Sagan and William Newman. They pointed out that Tipler might have underestimated the rate of replication, and von Neumann probes should have already started consuming most of the mass in our galaxy. Therefore, any intelligent race would avoid designing von Neumann probes in the first place and try to destroy any probes as soon as they found them. Another objection to the prevalence of von Neumann probes is that civilizations that could potentially design such devices have an extremely high probability of self-destruction before producing such a machine. In any case, the assumed capacity of von Neumann probes is unlikely in reality. But then, how about Oumuamua? These days, scientists are using high-tech scanners to examine a huge, cigar-shaped comet, which might or might not be an alien probe. One idea is that it's an extraterrestrial civilization spacecraft with broken engines wandering through our solar system. If that's the case, the object could easily be a von Neumann probe. Dr. Jason Wright from Penn State University thinks that a broken alien spaceship could move in exactly the same way as Oumuamua. Rather than moving through space like other space rocks, the 1,318-foot-long, 118-foot-wide space traveler is tumbling through the solar system. At the moment, it's traveling at a speed of around 200,000 miles per hour. In his blog, Dr. Wright says that if such derelict craft were not traveling fast enough to escape the galaxy, They could thermalize with the stars and end up drifting around like an interstellar asteroid or comet. They wouldn't have attitude control anymore and would eventually start tumbling. And it could distinguish them from regular interstellar asteroids. Plus, even though their propulsion was broken, their radio transmitters could work just fine. In any case, so far, it's just a theory, and further research is needed. What do you think? Is Oumuamua just a space rock or an alien space probe?
Guess what? Scientists have come up with a cool idea about some cosmic creatures saying hello to us from the center of the Milky Way. Astronomers are all excited about finding extraterrestrial life, so they're focusing their search right at the heart of our galaxy. Imagine stars in outer space, like super cool DJs, spinning their own unique beats. But instead of music, they send out these special signals called radio pulses. It's their way of saying, "Hey, what's up, universe?" These radio pulses are basically little bursts of energy that travel through space. They're not just random noise, though. They have a specific pattern that makes them stand out from all the other sounds out there. It's like a secret code or a special rhythm that only these stars know how to create. Scientists are super curious about these radio pulses because they think that maybe, just maybe, intelligent beings from other planets could be using them too. It's like a galactic language that they could use to talk to each other. So, these clever scientists created special tools and software to listen in on these signals. It's kind of like tuning into your favorite radio station, but instead of music or talk shows, they're trying to catch these cosmic beats. They're hoping to find those unique patterns that could be a sign of other space beings trying to communicate with us. They used a super cool telescope called the Green Bank Telescope in West Virginia to collect data and search for these signals. But here's the twist. They didn't find anything this time. No worries though, because their fancy software is lightning fast and it'll help them search even better next time. But why did they pick the center of the Milky Way for this ET life hunt? Well, that's because the galaxy's hearts are packed with stars. In other words, there should be many more planets in there, which means more potential places for life. Plus, if there are super smart life forms at the core of our galaxy, they could easily send signals to lots of planets all at once. Sneaky, huh? This whole thing is super exciting because it's the first time scientists have gone all out to search for these types of signals. They think that using specific frequency ranges and repeating patterns is a really clever way for ET beings to make themselves known. I mean, that combo is so unlikely to happen naturally, right? The best part is that they have this algorithm thingy that can go through a crazy amount of telescope data in just 30 minutes. So, even though they didn't find anything yet, they're confident that this speedy method will help them find evidence of advanced life in the future. How awesome would that be? As you know, humanity has been searching for buddies from outer space for a very long time. This research is just one of many attempts to find them. There's a whole institute dedicated to this mission in the US, SETI, or Search for Extraterrestrial Intelligence. So, naturally, the question arises, why haven't we found anyone yet? It's like we've been scanning the sky forever, hoping to catch a glimpse of advanced civilizations out there. But we get absolutely nothing. All this brings us to the famous Fermi paradox. It's like a big mystery that fuels the hunt for extraterrestrial intelligence. We think that if intelligent life exists, we'd have evidence of it by now. Maybe they're actually beaming out radio signals for us to pick up. Or maybe they're just broadcasting in general and we happen to stumble upon it. They could even have left cool artifacts in our solar system to keep an eye on us or just hang out. Heck, maybe they're building wild mega engineering projects, like gigantic solar panels around their stars. Or they could be getting all fancy and contaminating their stars with heavy metals just to announce their presence. So the search continues. We're not giving up just yet. And hey, maybe instead of just focusing on smart space beings, we should be on the lookout for any kind of life at all. Yeah, I know that a tiny microbe might not be as thrilling as chatting with friendly otherworldly creatures. But think about it. There could be lots of simple life forms out there. We're talking about simple organisms swimming in oceans, mossy creatures holding onto rocks, or the first signs of critters exploring their habitats. They might not be super brainy, but they leave their mark. Plus, they could be way more common and easier to find in our galaxy. Now take Earth, for example. There's a theory that our atmosphere used to have a lot of oxygen floating around. But oxygen is a bit wild and doesn't stick around for too long. It either escapes into space or bonds with other elements, changing into different things like carbon dioxide. Then, around 2 billion years ago, single-celled organisms decided to gobble up carbon dioxide and burp out oxygen, completely changing Earth's atmosphere. Life here transformed the very nature of our planet. And guess what? We can actually detect changes like that on other planets. Here's how. When we look at faraway planets called exoplanets, sometimes they cross in front of their parent stars. As the star's light passes through the planet's atmosphere, it gets all mixed up with different elements and molecules in the air. And you know what happens? The light changes its flavor and color in a special way. So imagine you had a glass of lemonade and you added some fruit juice to it. The lemonade would taste different, right? Well, it's kind of like that with exoplanet atmospheres. When we see the star's light that has traveled through the planet's atmosphere, it gives us clues about what's in the air and how it's different from just the star's light alone. So by studying these changes in light, we can figure out what kinds of elements and molecules are present in the atmosphere of a faraway planet. It's like a cosmic chemistry experiment, and it helps us learn more about whether there might be life out there. So right now, we can only study the atmospheres of big planets that orbit really close to their stars. But don't worry, NASA's Transiting Exoplanet Survey satellite is on the case. It's finding lots of interesting planets that we can check out more closely with the super-powered James Webb Space Telescope. This amazing telescope can even sniff out if there's too much carbon dioxide on other worlds. And okay, let's be real, our first contact probably won't be as flashy as in the movies. No exchanging secret codes or figuring out ET customs. We won't be chatting about funky bodies or habits either. Instead, the first hint of life out there will most likely come as a little wiggly line on a graph. It shows us that living creatures have really shaken things up on their home planet. Even simple life forms can have a big impact on their environment and leave behind a noticeable trace. Sure, it might not be as wild as battling space robots or epic adventures, but imagine this. Finding any kind of life beyond Earth would be huge. We'd be calling home, sending messages like, "Guess what? We're not alone in the universe." It would be an historic moment we're celebrating. And by the way, we've already begun to find organic molecules in space. It's not a full-fledged life as we imagine it, but it's still pretty neat. For example, we've already started to find organic compounds on Mars. And there's a teeny tiny chance that Mars once flourished with plants, and maybe even animals. This is just a possibility, but if it turns out to be true, it would show that the presence of living organisms in the universe is not as rare as it seems. The search for life in the universe is like a great detective game. We thought that finding it would be easier because they could do cool stuff like blasting radio signals or transforming their whole solar system. But looks like, in reality, things are much more complicated. Nevertheless, we shouldn't give up. Let's keep searching and hoping that this new study about radio signals brings some results. Whoa! A wall of fire spreads around the epicenter of the impact. It burns everything in its path. The waves raised by the explosion cover large cities, and earthquakes are so strong that giant skyscrapers fall like a house of cards. So, these are the possible consequences of the collision with the first interstellar object in history to visit our solar system. We discovered it in 2017, but we're still not sure what it is. An asteroid, a comet, or a spaceship of some outer space civilization. So far, scientists have named it Oumuamua. Sounds like a Hawaiian cow. Well, whatever it is, its speed is much faster than other asteroids, about 54 miles per second. At that speed, you could cross the US from coast to coast in less than 3 minutes. So this asteroid could travel from Earth to the Sun in about 2 months. By comparison, our rockets can travel up to 17,000 miles per hour. The same trip across the United States would take them about 9 minutes. So many scientists speculate that this is an artificial object created by a very advanced civilization. Okay. The shape of the object supports this theory. It's long and narrow and resembles a spaceship. It's about half a mile long, way bigger than the Eiffel Tower. Scientists decided to see if Oumuamua was really someone's spaceship and pointed some radio telescopes at it. If the civilization on that ship had used communication or scanned us with their tech, we would have known about it. But there was complete silence. Kinda like that. Not a single radio wave. But that doesn't disprove the theory of outer space civilization. To find out for sure, we decided to determine the weight of the object. To do that, we use light. More precisely, its reflection. You see, different materials reflect light differently. We take an unknown black stone, for example. It absorbs almost all the light, reflecting almost nothing. Check out the catalog, it's charcoal. Knowing the size and material of the object, we can determine its weight. So, we need to see how much light this object reflects. And when scientists pointed their telescopes at Oumuamua, they learned that it reflects colors that match with iron and also with some solid rocks. And Oumuamua was flashing all the time, a bright flash. Then it would slowly fade, and then it would start to shine again. This means it was spinning. And it wasn't going around its axis like an arrow. It rotated chaotically, moving its edges up and down. Any artificial object or spacecraft would have been torn apart by such overloads. But Oumuamua is still intact. That means it's made of super hard materials that keep it from falling apart. And it's not hollow like a spaceship. It's one solid body. Hey, like me. The astounding speed of this object makes it pretty mysterious. Some comets can have the same or even higher speed, but they also have a kind of rocket effect. So when a spaceship starts from the launch pad, you see fire bursting out of its engines. Every second, the rocket mixes fuel with oxygen, ignites them, and ejects them at a tremendous speed. According to the laws of physics, this is like pushing off a wall. The rocket sort of jumps up from the combustion gases it throws down. That's how the rocket creates thrust and accelerates. Comets work on a similar principle. The sun's rays hit the surface of the comet. Light elements like ice start to evaporate. That gas goes one way, the comet goes the other. Just like a rocket, the comet is pushing off the evaporating gas and accelerates. This gas also forms the comet's long tail. It's as if the massive rock is dragging all this gas behind it. I can relate. Or it's like a car pulls air with it when it goes at high speed. But Oumuamua is not a comet, and it doesn't have that tail, and it doesn't have the same rocket effect as a comet. So it couldn't have accelerated to that speed. But some scientists believe that Oumuamua used to have a tail. Although we discovered it in 2017, it entered our solar system in 1995, and it was hit by the sun's rays even back then. When we discovered this asteroid, it had already lost about 95% of its mass. It simply evaporated. Other scientists believe that Oumuamua got this velocity during its birth, somewhere far away in another star system or nebula. Perhaps it was a dramatic collision of some exoplanet with another cosmic object. The colossal explosive energy of the collision threw the elongated shard into outer space. Or it could have been a supernova explosion. When a star reaches the end of its lifespan, it becomes a red giant. It's an inflated version of the star, hundreds of times bigger. Then it shrinks and explodes with tremendous force. The blast waves can travel many light years away from the epicenter, and it's one of the brightest events in the universe. So the supernova might have torn some exoplanet to pieces. One of them, Oumuamua, gained a lot of energy and speed and began its long journey toward Earth. This might explain why Oumuamua keeps spinning so wildly. But recently, scientists published a theory that Oumuamua may be a giant block of ice. The kind of ice we're used to is water, H2O, but Oumuamua could be nitrogen ice, N2. It may have remained intact in interstellar space for 500 million years. And when it arrived in our solar system, nitrogen ice could have reflected 2/3 of the sun's rays, so it didn't heat up as much. That explains why Oumuamua doesn't have a tail. You can find the same nitrogen ice on Pluto, as well as on Triton, one of Neptune's moons. So Oumuamua comes from a similar icy exoplanet. But we can find out for sure only by sending a space probe to it. Scientists came up with a plan for that called Project Lyra. The problem is that Oumuamua is leaving our solar system at tremendous speeds, much faster than our rockets can fly. And we need to catch up with this space rock as quickly as possible before it gets too far away. To do this, we can use a gravity maneuver. First, the space probe makes a flyby of Jupiter. It passes close to it to take advantage of its gravity to accelerate. After that, the probe will head towards the Sun, and it'll fly around it as close as possible to fire like a catapult towards the space rock. The second option for reaching the asteroid is to use microprobes. We have to launch about 1,000 of them into orbit. They should be no heavier than a match. Each of them will have a light sail the size of a boxing ring. Then we'll focus a powerful laser beam from the ground onto this sail. It will allow us to accelerate the probe to about 20% of the speed of light. It shouldn't go too fast not to fly past the asteroid. It should be able to enter its orbit or land on it. But if we're too slow, Oumuamua will leave our solar system before we can catch up with it. It'll be a great experience because in the future, we'll be able to use such asteroids as a space taxi. All we have to do is enter the orbit of such an interstellar asteroid or even land on it. Then we would keep moving through space at incredible speeds without using any fuel at all. This would be a great option for traveling long distances or to deliver supplies to other star systems. So why should we be afraid of such objects? Well, a collision with an asteroid the size of Oumuamua could wipe out an entire state. If it were to hit somewhere in the ocean, it could cause waves taller than our skyscrapers. Scientists are anxious to find ways to protect us against such objects. One of them is ramming. If we spot a potentially hazardous object, we could send a spaceship towards it, pedal to the metal. The spacecraft will have to ram the asteroid at an angle that will move its trajectory just a little bit. Moving it too much on a cosmic scale would only dramatically change the asteroid's final destination, and we only need to get the asteroid past our planet. We can also create a controlled explosion on the asteroid. It's based on the same principle. The force of the explosion would have to shift the trajectory of the asteroid slightly, or smash a giant rock into smaller pieces. Asteroids up to 80 feet wide would burn up completely in our atmosphere due to friction against the air. Rocks between 80 feet and half a mile in size may not burn up completely and cause local damage. Anything larger is considered very hazardous. You think? The traditional method of science fiction is to put rocket engines on the asteroid. Then we can not only change the trajectory of the space rock, but also control it. And we can use it against other asteroids. It would be something like space billiards. You know, many different things have nothing in common at first glance. The appearance of mysterious clouds over Stonehenge and the migration of wolves in Canada. Patterns on the wings of a Caribbean butterfly and strange footprints on the moon's surface. These are all random facts, but people can see connections in these events. Let's see how it can happen and where it can lead to. Imagine reading some crazy article on one of the unreliable sites, forgetting about it, and then beginning to notice small details in the world that might indicate that the information in this article is true. You realize you've learned something unusual, but for some reason, other people don't see it or don't want to see it. You try to tell them, but no one wants to listen to you. And some people even think you've gone mad. Let's stop for a moment and see what kind of article you've read. So, in 2017, one not-so-truthful site published a story about a ship from another planet called Black Knight that had been spying on people for 12,000 years. But not long ago, agents from a secret organization managed to destroy it. Sounds like absolute nonsense or a plot for a cheap sci-fi movie. Of course, you don't believe it. But a few years later, you find a story about Nikola Tesla. Let's fast forward to 1899. The famous scientist was sitting in his laboratory in Colorado Springs conducting radio experiments. Suddenly, his receiver caught a strange radio signal. Then, after a while, another one. The signals came in with the same time interval, as if someone wanted to send a message. Nikola Tesla realized it could be something from extraterrestrial civilizations that were trying to start a dialogue with people using the most universal language, math. He also reported about this event in a magazine at the beginning of the 20th century and added that he hadn't deciphered the message. Okay, now let's forget about it and see what happened next. In 1927, an engineer from Oslo, who was fond of radio devices, was sending signals into open space. He was surprised when, sometime later, the same signals began to return to his receiver. It was as if the signals bounced off something big and echoed back, or something received these messages and then sent them back to the sender to make an acquaintance. The man quickly reported his discovery to scientific journals, and perhaps someone connected this event with Nikola Tesla's words about strange signals from space. All this were just prerequisites for the Black Knight. But the most exciting events started decades later. In the 60s, Time magazine published an article that said that the U.S. had discovered a satellite orbiting Earth and using unknown technology. A couple of years later, Project Mercury astronaut Gordon Cooper reported that he had seen a strange object during his spaceflight. But the Black Knight became really famous only in the late 90s, when NASA published a series of images of a mysterious object. During the first flight to the ISS, astronauts noted weirdly shaped somethings and took several pictures. Then someone gathered all the facts, collected all the information about the black satellite, and discovered that it had been flying around our planet for more than 10,000 years. How did they figure it out? People managed to calculate the age of those radio signals that Tesla and the engineer had received. If this is true, the Black Knight appeared much earlier than the Sumerians in ancient Egypt. What if this satellite helped build pyramids and majestic temples? What if it had been watching over our development all this time and transmitting this information to another planet? What if mysterious images ancient people drew depicted the satellite? People began to suspect NASA and other space agencies of hiding information about the black object to prevent panic. And now, after having received all the data about the mysterious satellite, you might begin to suspect that the bizarre article may actually be true. This news is so improbable and ridiculous that no one will believe it. If you want to hide something, hide it in plain sight. And so, together with other enthusiasts, you start hunting for any information about the mysterious ship. You create forums, post photos of unknown objects, and become obsessed with this topic. You really believe in the reality of the Black Knight. Moreover, you don't want to question its existence. And people reading your articles do the same. Congratulations! You have become an ideal candidate for creating fake news in the yellow press. Such myths and urban legends seem attractive. The human brain feels pleasure when it finds fake secret information. The feeling of mystery, adrenaline, and shock can cause psychological addiction. That's why the stories about the Black Knight are still alive. Mysterious facts seem logical, and people stop seeing information that refutes their theories. The case of the Black Knight is no exception. The fans of this black object believe that Nikola Tesla received signals from some space civilization. But for some reason, they don't attach importance to scientific articles, which say that such radio signals could be sent by giant space objects like pulsars. A pulsar is a rotating neutron star emitting powerful electromagnetic radiation. Such radiation is often found in space. These radio waves don't imply the presence of a mind and a sender. The cosmos is full of such signals. The technology for detecting such objects were created in the 60s. Or maybe Tesla's device caught a signal coming from our planet. Besides, the scientists didn't say anything about the Black Knight. So why did people connect these two events? That story with the Norwegian engineer is still unexplained. Yes, his signals returned as an echo, But this had nothing to do with the flying object in question either. You might as well say that the satellite somehow influenced the Titanic. There's no logic in such assumptions. Strangely, no one connected the Black Knight with the Yeti or the Kraken. Now, let's return to that Times article about a strange object flying around Earth. It also stated it was a fragment of an American reconnaissance satellite. But fans of myths and legends apparently didn't notice this explanation. As for astronaut Cooper, who is said to spot some object during his mission, he actually saw nothing. He even showed a transcript with no reports about the black satellite. However, some believers in other civilizations keep silent about this fact. So, the main proof of the Black Knight's existence is the photos taken during the first flight to the ISS. The astronauts noticed this strange object and took pictures, but it wasn't a surprise for them because some part of the ship broke away during some work they did outside. It was a piece of thermal coating. The astronauts sent the photo to NASA, and the space agency assigned it a personal number, as it does with all such objects. A few days later, the Black Knight fell out of orbit and burned up in Earth's atmosphere. Almost all this information was recorded in official protocols. One of NASA's engineers, who knew the photographer of the black satellite, explained that those famous photos depicted an ordinary piece of the ship. There was nothing fantastic about it. But the fans of extraterrestrial rockets must have missed all this information. All these myths have long been debunked, and all the false facts have been refuted. But the Black Knight continues to live in many people's minds and on the pages of the Yellow Press. It has become a link between many reports of strange flying objects. Over the years, hundreds of stories have appeared about secret laboratories with extraterrestrial technologies, about NASA hiding secrets, and about creatures from other planets. And many people connected these myths with the black satellite. It has stopped being a real physical object. Now it's a cultural phenomenon. Remember how the main symbol of extraterrestrial civilizations was a flying saucer? It's not trending anymore. Today, the symbol is a black, weirdly shaped stone. Don't be fooled.
The James Webb Telescope, or JWST, is like the ultimate intergalactic paparazzi. It takes pictures of some of the most famous celebrities in the universe. Stars, galaxies, exoplanets, you name it. The James Webb Space Telescope will snap a photo. So if you're a fan of cosmic celebrities, let's take a look at some of these best star-studded photos. The Carina Nebula. The image of the nebula with the beautiful name Carina was published on July 12th. JWST captured a beautiful view of the nebula, located about 7,500 light-years from Earth. Nicknamed the Cosmic Cliffs, it is, in fact, a hotbed of young stars, some of which are several times larger than our Sun. The Carina Nebula is a celestial spectacle located in the southern constellation Carina. It's really huge, approximately 260 light-years across. Massive stars within this nebula are so bright and hot that they create a glowing cloud of gas and dust around them. The Carina Nebula also contains swirling clouds of gas and dust where new stars are being born. The gas collapses under its own weight, becomes hotter and denser, and all this eventually leads to the creation of new stars. However, the Carina Nebula isn't just some peaceful place of star formation. It's the site of some of the most destructive events in the universe, which create massive shockwaves that obliterate everything in their path. Very chaotic and cool. The Stefan's Quintet. This photo was also posted on July 12th. Stefan's Quintet is a visual group of 5 galaxies located at a huge distance from us. About 290 million light-years in the constellation of Pegasus. It's like a cosmic family reunion. All these galaxies are related to each other and interact with each other in some interesting ways. They're pulling and tugging on each other with their gravity, constantly exchanging gas and dust. This interaction is causing some of the galaxies to collide and merge, which can create all sorts of cool effects. like bursts of star formation and supernovae. Thanks to JWST, we were able to see shockwaves, tidal tails, and other amazing details about these galaxies. Their interactions create a stunning sight that we can see in this photo. Jupiter. And here's our old giant friend. This image was published by NASA on August 22nd. Jupiter is the largest planet in our solar system, and it's known for its many moons and its beautiful swirling clouds. But it also has a system of rings, just like Saturn, which are made up of tiny particles of dust that orbit the planet. These rings are much smaller and less visible than Saturn's, but they're still pretty neat. Jupiter also has auroras, which are colorful light displays that occur in the planet's atmosphere. They're caused by charged particles from the solar wind interacting with Jupiter's magnetic field. Just like on Earth, they can be seen near the poles of the planet. But these auroras are much brighter and more intense than ours. We can even see this crazy light show from space. And now, we were finally able to capture this dazzling sight. JWST's photo shows the auroras of Jupiter, its rings, and even two moons, Amalthea and Adrastea. It's amazing how bright and clear they are on this photo. The Cartwheel Galaxy. NASA released this image on August 2nd. This photo shows us the Cartwheel Galaxy and its companions. The Cartwheel Galaxy gets its name from its shape. It kind of looks like a cartwheel, doesn't it? This is a giant swirling mass of stars, gas, and dust, which is located in the depths of space. It's shaped like a pinwheel with long spiral arms. These arms are held together by the gravity of the central region, which is home to a supermassive black hole. But the Cartwheel Galaxy is a bit different from its spiral relatives. It has formed when a smaller galaxy collided with a larger one, creating a shockwave that rippled through the gas and dust. We'll definitely have to visit this galaxy someday. It's sure to be a wild ride. Spiral Galaxy M74. And here comes another spiral galaxy. NASA released this image on July 22nd. JWST had to peer through thick layers of dust and gas to see this beautiful star cluster. M74 belongs to a special class of spiral galaxies known as the Grand Design Galaxy. This means that its spiral arms are noticeable and clearly outlined. All sorts of amazing things are happening inside of spiral galaxies. Supernovas, stars being born in clouds of gas and dust, and many other cosmic wonders. The glowing gas and dust, the bright stars, and the swirling patterns of the spiral arms make them some of the most striking objects in the universe. Well, we can clearly see it on the example of M74. The Tarantula Nebula. This image of the nebula with a creepy name Tarantula was published on September 6th. The photo covers as much as 340 light-years across. This is a huge distance. Thanks to this image, astronomers have discovered new young stars that were previously shrouded in dust. The Tarantula Nebula is located 160,000 light-years away from us, in the Large Magellanic Cloud. It's the largest and brightest star-forming region in the local group, the galaxies nearest our Milky Way. It's named after its shape, which looks like a bit like the legs of a big tarantula. It's a vast region of space, about 1,000 light-years across, and it's home to some of the most massive and luminous stars in the universe. One of the reasons why the Tarantula Nebula is interesting to scientists is its composition. Its composition is close to the region of stars of the cosmic noon, the so-called state of our universe when it was only a few billion years old. At that time, star formation was at its peak. Thanks to the Webb telescope, we can study this galaxy better and find out what our universe was like at its peak. Neptune's rings. This photo was published on September 21st, 2022. In this photo, we can even see 6 small moons next to the planet, with Triton shining brightly in the upper left corner. You didn't think it was the sun, did you? And yep, Neptune has rings too. They're like the ultimate cosmic accessory. They add a touch of glamour and style to the planet. But unlike some earthly bling, these rings are made of small particles of dust rather than diamonds and gold. There are 5 known rings around Neptune: the Gall, Leverrier, Lassell, Arago, and Adam's rings. Scientists think that these are relatively young, much younger than our solar system and much younger than, for example, Uranus's rings. They were probably created when one of Neptune's inner moons got too close to the planet and was torn apart by gravity. We haven't seen Neptune's rings so brightly since Voyager 2 flew past it back in 1989. So this is a great opportunity to take a closer look at these rings. The Pillars of Creation. This photo was published on October 19th. The Pillars of Creation became famous thanks to the Hubble telescope, but this photo is very lush and much more detailed. These columns, located in the Eagle Nebula, are about 5 light-years tall, which is really, really long. And they look like some majestic rock formations, only much more transparent. Just like a typical Hollywood movie set, they're full of action and special effects. They're home to some of the most dramatic processes in the universe. The gas and dust are collapsing under their own gravity, forming clumps that will eventually become stars. The place is full of intense radiation, jets of high-energy particles, and supernovae. It's like a cosmic version of Survivor. And if this wasn't creepy enough, here's another photo published by NASA on October 19th. They shared it right before Halloween. Here, the pillars resemble an eerie hand reaching for something. Brrr. Anyway, all these photos give us a truly awe-inspiring sight. They remind us of the incredible complexity of the universe and the amazing things that are happening even in the darkest and most remote corners of the cosmos. Let's hope that the James Webb Telescope will continue to amaze us in the future.
Aliens have invaded Earth and they are not here for friendly interaction. It all begins with the detection of an extraterrestrial signal by the SETI network. This isn't just random space noise. This is a clear sign of an alien civilization. Once the information reaches world governments, rumors start circulating that aliens are on their way to Earth. The US, Russia, and China are the first to learn of the threat, but all governments try to keep the news secret, knowing that widespread panic could lead to catastrophic consequences. At first, nothing happens. Days turn into weeks, and skeptics begin to mock the very idea of an invasion. News channels call it a hoax, while conspiracy theorists claim it's a government distraction. People continue their daily routines, unaware that something is already approaching at an unimaginable speed. Then, without warning, they arrive. Their ships break through the atmosphere, not in a slow cinematic descent, but in an instantaneous burst of speed, defying human understanding of physics. The first crafts land in major cities across the globe: New York, Moscow, Beijing, London, Tokyo. Within hours, the entire planet is covered in their presence. Authorities still don't know who these beings are or what they want. Are they destructive creatures seeking Earth's resources? Or perhaps they want to expand their empire? Another theory emerges. Maybe these invaders are artificial intelligence created for space exploration, no longer dependent on planet conditions for survival. Attempts to communicate prove futile. Linguists, AI systems, and mathematicians fail to decipher their signals. Then comes the first attack. In one swift moment, a military base in Nevada is wiped off the map, leaving only a perfectly circular crater. The world realizes that this is not a peaceful encounter. The aliens begin their offensive, and it becomes clear that they are not here for diplomacy. Earth, rich in minerals, water, and other valuable resources, is an ideal target. Their technology far surpasses ours. Despite our best efforts to resist, our military stands no chance against their lasers, nanotech, and antimatter bombs. Even the United States, with its trillion-dollar military budget, can't match the alien technology. As they destroy key military bases and power infrastructure, the world is plunged into darkness and chaos. World powers begin to cooperate, but nuclear weapons are considered a last resort, knowing that using them could doom the planet. With cities in ruin and society unraveling, millions of civilians are forced to flee to remote areas, hoping to survive. Meanwhile, scientists scramble to understand alien technology, hoping to find ways to protect Earth or develop vaccines against possible biological threats. The global communication network is broken, and humanity is on the brink of collapse. The aliens continue their systematic destruction of Earth's defenses. Satellites are taken out, cutting off global surveillance. Drones and fighter jets fall from the sky like birds caught in a storm. Entire armies are reduced to ash in seconds. Panic spreads. Governments collapse. The world's leaders either go into hiding or perish in the initial wave of destruction. Civilization, as it was known, is no more. As time passes, the alien technology continues to overpower us. Our military forces are crushed, and our only hope now lies in guerrilla warfare by civilians. The United States, with its high number of privately owned firearms, may have a better chance than other nations, but it's still unlikely that we can withstand the alien onslaught. Small resistance groups form in hidden bunkers, underground tunnels, and abandoned cities. They communicate through salvaged radios, sharing whatever knowledge they have about the invaders. Some manage to take down individual alien soldiers, but their victories are short-lived. The aliens adapt quickly, learning from human tactics, neutralizing any newfound weaknesses. However, there's another possibility. Maybe the aliens aren't here to destroy us. There's a theory that such an advanced civilization might have evolved to be peaceful, having long overcome the destructive tendencies that lead to war. Another theory suggests that aliens might not need Earth's resources, as space is abundant with energy and rare minerals. Alternatively, they might just be studying us, like creatures in a zoo, observing our progress without interference. But reality sets in once more. The aliens proceed to the next stage of their plan, terraforming Earth. This could involve altering the atmosphere by releasing gases like methane or ammonia, slowly making the planet inhospitable for humans. They may also manipulate the oceans, changing their acidity or salinity, which would destroy marine life. To further reshape Earth, the aliens activate dormant volcanoes and trigger earthquakes around the globe, either to alter the planet's environment to their liking or to access resources more easily. As Earth becomes increasingly unstable, the aliens complete their conquest, and humanity's numbers dwindle. Those who remain are used for genetic experiments or research. Our bodies, brains, and memories might be studied, or we could be wiped out altogether in a matter of days. Earth would be left a barren, lifeless rock drifting through space. However, perhaps the aliens aren't as hostile as we think. Maybe they don't want to conquer us, but instead just want to observe us, like we study animals in a zoo. Maybe, over time, they would want to cooperate with humanity and help us grow. Or perhaps, this is just the beginning of a new era for Earth.
The very first known interstellar object, or ISO, to pay a visit to our solar system was a rocky, elongated interloper with a slightly reddish hue. It was spotted in 2017 and was dubbed with the Hawaiian name Oumuamua. It was almost 10 times as long as it was wide, and it was extremely unusual. Objects in our solar system are rarely shaped this way, so astronomers hoped it could provide some clues into how other star systems form and function. For hundreds of millions of years, longer than I've been around, this bizarre guest has been wandering through our home Milky Way galaxy, not bothering to settle down in some star system. And then, it came across the solar system. After the space traveler was discovered, hundreds and probably even thousands of telescopes all over the world, including ESO's Very Large Telescope in Chile, sprang into action. They started measuring the object's orbit, its color, and brightness. That's when it became apparent that the space rock had an unusual orbit. Some astronomers suggested that Oumuamua was emitting hydrogen it had picked up during its journey between stars. This was a simple explanation for the mystery that had evoked lots of outlandish theories. When this bizarre guest was first spotted upon entering the solar system, scientists were not sure what its nature was. Some claimed it was a comet. Others disagreed, saying it didn't have the features typical for comets. a visible long tail, and a coma, which is a cloud of gases surrounding the nucleus of a comet. Plus, its shape was different from that of other comets. The only thing that made Oumuamua more comet-like was the way it accelerated as it went away from the Sun. The unusual object started to slow down on its way out, but in a strange way, as if not only gravity was in play there. It seemed like something was creating a force to counter this gravity. But unfortunately, this theory didn't quite fit either. The problem is that comets usually have large quantities of water ice on their surface, and as the Sun heats this ice, it gets ejected as jets of gas. Those jets act as mini rocket boosters. But Oumuamua not only had no tail whatsoever, but it was also too small to capture enough solar energy to support this kind of activity. Of course, this mysterious space visitor caused some more outlandish theories. For example, some people started to claim that Oumuamua could be a spacecraft sent by a civilization living in another star system. However, scientists found a better explanation. A comet that is traveling between stars gets cooked by cosmic radiation. These rays penetrate thick layers of ice, converting up to 25% of water molecules into molecules of hydrogen. And then, this trapped hydrogen gets released when some star warms the comet. The effects of this process are almost invisible. This might be the reason why we didn't see a spectacular tail accompanying Oumuamua. At the same time, the potential comet was so small that this could produce enough force to power its acceleration. As for the amount of ice released as Oumuamua was coming closer to the Sun, it was likely too small for astronomers to spot it. Now, even though Oumuamua was the first known interstellar object to enter our solar system, it wasn't the last. In August 2019, comet 2I Borisov visited us, becoming the second ISO astronomers managed to spot. Now, no one can argue that there simply must be more visitors from faraway star systems than those two. ISOs are rare, but our solar system is pretty old. It must have been capturing some interstellar travelers over the millions and millions of years of its existence, even though they never stayed for very long. One study has taken a closer look at interstellar objects, and they concluded that these space travelers might be caught not in solar orbits, but in near-Earth orbits. The astronomers working on this project even go as far as to claim that there might be a lot of ISOs in orbit around Earth. Now, finding tiny objects in the vastness of the cosmos is extremely tricky. Think about it. What images of distant areas of space do we usually get? Mostly stars. Sometimes unclear pictures of exoplanets. Even more rarely, it can be disks of debris. But fine detail in small space objects? Almost never. So it's actually lucky for us that other solar systems send their inhabitants to visit us. Because by studying ISOs, we gain insight into the formation, evolution, and functioning of other star systems. Have you ever heard of the Oort cloud? It's the most distant region of our solar system, and it's quite unusual. You see, the orbits of the planets lie mostly in the same flat disk surrounding the Sun. But the Oort cloud is believed to resemble a spherical shell surrounding the entire solar system. It looks like a gigantic, thick-walled bubble made up of chunks of ice and other space debris as large as mountains or even bigger. Astronomers think that the Oort cloud contains billions, if not trillions, of different objects. There might also be a connection between the Oort cloud and ISOs. Because scientists think that interstellar objects might outnumber those from the solar system in this region. Even though no one has ever observed the Oort cloud directly, astronomers are sure it does exist. They made such a conclusion after observing the distribution of comets in our solar system. The Oort cloud could have formed from debris in the early solar system, but some experts argue that the largest part of this unusual shell could be interstellar in origin. If travelers from other star systems are as common as some studies suggest, lots of the bodies on the edges of the solar system are likely to have originated in other systems. Sadly, this theory hasn't been proven yet. Now, since we've been talking about comets, not Cupid or Donder or Blitzen, one of them has recently approached the Sun at breakneck speed. It was 96P Mach-Holz 1. This comet is around 3.7 miles wide, and astronomers think it might have arrived from outside the solar system. The NASA European Space Agency Solar and Heliospheric Observatory spacecraft has been monitoring the comet. So look at this. That's the comet's tail. It's mostly made up of gas. It's trickling behind frozen chunks of ice that are getting heated by the radiation coming from the sun. In some cases, a comet can have two tails, one made of dust and the other consisting of gas. And each of them can reach hundreds and, in some extreme situations, even millions of miles in length. In 2008, scientists analyzed the material left by 150 comets. They found out that the comet we're talking about was quite low in carbon and didn't contain a large enough amount of some other typical materials. This could only mean one thing. The comet was an interloper coming from another star system. It may have been ejected from its original solar system by the gravity of a large planet. After that, the poor homeless thing probably spent a large amount of time wandering around space, until it came across Jupiter. The gas giant could have bent the comet's trajectory, trapping it in orbit around the Sun. There's one more theory. According to it, the comet formed in a poorly studied region of the solar system, and it has this weird composition due to its repeated journeys around the Sun. Now, scientists are watching the comet with anticipation, like Christmas. Since it's an atypical one, both in its behavior and composition, they don't know what they will see, which makes the whole process even more exciting. Most comets falling toward the Sun are quite small, not more than 32 feet across. That's why they burn up as soon as they come close to our star. But the sheer size of Mach-Hulse 1, which is more than 2/3 the height of Mount Everest, seems to protect the comet from evaporating completely.